Okay, this is a follow-up to my mag motor using the Starship coils rather. This unit, I pulled a couple of them off here that weren't hooked up, but these are actually mounted on the board. I have a total of 6 of them on that side, and I plan to put some others on here. Of course, this is the Hall effect transistor that controls this circuit here, which it basically just goes into a 2N222 and is amplified to going into a 2N3055, and then which feeds from the power supply, a 12-volt power supply, into just 2 of these coils. So 2 of the coils drives this wheel with 9 neodymium magnets on it. The 2 coils that do drive it are in parallel, hooked up in parallel to the circuit. Well, I was going to show basically, I was testing the circuit, not the motor part, but actually seeing what kind of power we can generate from the other coils where the magnets are running over it. And one thing I noticed is the first time I hooked up a lot of these coils, as you notice, there's a spacing in between each of the coils. But when the magnet runs over one of these Starship coils, basically you get a pattern on the scope. If you can see that, it has it goes into when the magnet starts passing over the Starship coil, it does a negative dip, then it gets to the center and does a positive high. And then as you notice, it looks like a chair step where it goes into a null zone for uneven space before it starts to cycle again. I attributed that, my theory was attributing that to the spacing between the 2 coils. And I was correct. What I've done now is I've taken, that's the signal coming from this one coil right here. And what I did, I hooked this in series, not in series, but in parallel with this other coil that's not attached to the board. And what I do is, by making up that space, I'm going to the top side, evenly spaced, and I'm going to just kind of hold it. So if I can hold it there, you can see the scope is kind of dark. I don't know if I'll be able to do this. Well, I probably can if I can come over here. Alright, there you go. I'm going to drop this down the middle of one section. You'll start to see what I'm talking about. It'll start to become a side. There you go. So by spacing it down, it actually turns it into a full sine wave. So that's the setup that I think I'll end up doing, is that a full set to create a full sine wave will actually be one on the bottom and one layered right in between, so it gets the full benefit of the cycle. Those will be hooked up in parallel. All the other coils will always be sets of 2 I will hook up in series, so I can increase the voltage coming out of the device. And of course, this is all right now just pulling directly off the magnet. I may basically try to experiment with I hadn't even started experimenting with the high frequencies driving it. And there's a lot more power you can get out of square wave higher frequencies instead of just relying on pulsed DC coming from the Hall effect transistor. HHOforVolts basically did a lot of research with this, and quite a number of others. But it's interesting to find out for myself how all this is going to work. This is the circuit where I have basically an NE556 chip, and it will actually drive, it's the timer that will drive a MOSFET, power MOSFET into the circuit, replacing what you see here. This was just the basic one just to get this motor running. Now currently, with 2 coils, it looks like it's running about 13 volts, dropping checking with the amps, it's about 1 amp. So we're talking about a 13 watt unit. This thing is actually being driven on 13 watts. And the speed, of course, I hooked up a Radio Shack meter that actually has can measure the frequency counter on it. So it's up to 19 hertz. If you divide that down by the number of magnets on here running across there, that basically comes out to about 2 RPMs per second, which of course that translates to 120, 130 RPMs as far as the speed. I haven't been able to get much more speed out of this. I'm really depending on the fact that once I start driving these two push coils with higher frequency energy, that there will be a lot more push coming out of that. So anyway, and I'm also going to be experimenting. I picked this up some time ago at a hand fair, capacitance meters. So I'm going to be experimenting with resonance circuits as well too. There's a lot that has to do with a combination of resonance circuits, the frequency you pick, and the configuration of the coils. So this is where I'm at, and of course I peruse through YouTube getting ideas, but things are getting a little bit clearer here. So thought I'd throw this in there, thought I'd put this video out, I'll post it, and we'll talk to you later. Thanks.